Welcome back. In this video, we are going to discuss about the fundamentals of data structures and what are the various fundamental data structure that we are going to consider, that we are going to study in this particular subject, analysis and design of algorithms. The data structures play an important role in designing of algorithms. Since it operates on data and legitimate input is a key thing for an algorithm, so we need to understand about the fundamentals of data structures. A data structure can be defined as a particular scheme of organizing related data items. The data items range from elementary data types to data structures. So the first type what we are going to discuss is the linear data structures. The two most important elementary data structures are array and linked list. Array is a sequence of contiguous memory location and are made accessible by specifying a value of the array's index. Suppose if we have an array as item, the array index values are item of 0, item of 1, item of 2 up to item of n minus 1. So the index values ranges from 0 to n minus 1 for an n-dimensional array. Each and every element in an array takes the amount of time to access, and it also takes the amount of time to store in the computer as well. Arrays are also used for implementing the other data structures. One among them, the common is string. String means a sequence of alphabets. It's terminated by a null character. The null character specifies the end of the string. The strings composed of zeros and ones called binary strings or bit strings. The common operations performed on the strings are concatenation and finding the length of the string, copy the string, compare the string, like this. A linked list is a sequence of 0 or more elements called nodes, each containing two kinds of information. The linked list nodes have a data link, data and a link. The link is a pointer to the other nodes of a linked list. A pointer called a null is used to represent no more nodes. In a singly linked list, each node except the last one contains a single pointer to the next element. The single linked list will have n elements. The elements stored like this: item 0, item 1 up to item n minus 1, and it ends with null. To access a particular node, we start with the first node and traverse to that pointer until the particular node is reached. The time needed to access depends on where in the linked list the element is located. But it does not require any reservation of computer memory. Insertion and deletions can be made efficiently. There are various forms of the linked list. One is we can start a linked list with a special node called a header. This contains the information about the linked list such as its current length, also a pointer to the first element, a pointer to the last element. Another form is called a doubly linked list, in which every node except the first and the last contains the pointers to both its successor as well as the predecessor. The last more abstract data structures are called a linked list or a simply list. It's a finite sequence of data items arranged in certain linear order. The basic operations performed are searching for inserting, deleting an element. Two special types of the lists are stacks and queues. The stack is a list in which insertion and deletions can be made only at one end. This end is called a top. The two operations done are adding and deleting the elements to a stack. It's used in recursive algorithms where the last in first out fashion is used. Next is a queue. Queue is a list for which elements are deleted from one end of the structure called front, and if new elements are added to the structure, the other end called rear. It operates in a first in first out basis. A priority queue is a collection of data items from a totally ordered universe. The principal operations are finding its largest elements, deleting its largest and adding a new element. Better implementation is based on the data structure called a key.